Hello everyone, I'm Akash. In today's video, we will solve another question on complex analysis from Maharashtra State 2024 exam. Question is, the residue of the function f of z defined by e to the power z minus 1 upon z square at point z equals to 0 is what? And these are the options. So let's begin the solution. We know that if function f of z has pole of order m at point z equals to z0, then the residue of f of z at z equals to z0 is given by the formula limit z tends to z0 1 upon m minus 1 whole factorial times m minus 1th derivative of z minus z0 to the power m times f of z. Okay. So if the function f of z has a pole of order m at point z0, then the residue of f of z at z0 is given by this formula. We will use this formula to find the residue of the given function at point z equals to 0. But to apply this formula, we need to confirm whether this function has pole of some order at point z equals to 0 or not. So we need to first verify whether z equals to 0 is pole of this function or not, and if yes, then we need to find the order of this pole. So let's first verify that z equals to 0 is pole of this function or not. Clearly this function has only singularity at point z equals to 0. Okay. By definition of this function, we can see that z equals to 0 is the only point of singularity. So certainly it must be an isolated singularity. Okay. And we know that if z0 is an isolated singularity of f of z, then z0 is a pole of order m if limit z tends to z0, z minus z0 to the power m times f of z is non-zero. If z0 is an isolated singularity of f of z, then z0 is a pole of order m of f of z if this limit is non-zero. Clearly here, as z equals to 0 is only singularity of f of z, so it must be an isolated singularity of that function, and so we can apply this result to determine whether z equals to 0 is a pole of order m of the given function or not. So let's calculate this limit. Limit z tends to z0 is 0, z minus 0. Let's take m equals to 1 and we check whether the limit not equals to 0. Okay, so let's take m equals to 1 times f of z e to the power z minus 1 upon z square. So this cancel out and the limit becomes e to the power z minus 1 upon z. So it is 0 by 0 form, so we need to apply the L'Hospital's rule, and so by L'Hospital's rule this limit becomes e to the power z upon 1. So this is nothing but 1, not equals to 0. Limit z tends to 0, e to the power z, which is 1, not equals to 0. So we can see that this limit is non-zero. So according to this result, the function f of z has pole of order 1 at point z equals to 0. So now we have the value of m, which is 1, and the value of z0 is 0. That is, the function f of z has pole of order 1 at point 0. And just we need to substitute these values in this formula. So the residue of f of z at z equals to 0 is the limit z tends to 0, 1 upon m minus 1 whole factorial. Value of m is 1. So 1 minus 1 whole factorial, that is 0 factorial, and the value of 0 factorial is 1. So 1 upon 1, nothing but 1. And the m minus 1th derivative, and m is 1. So 0th derivative of this function, that is nothing but this function itself. So z minus 0 to the power 1 times f of z. F of z is e to the power z minus 1 upon z square. So we need to just evaluate this limit, and this is nothing but limit z tends to 0 e to the power z minus 1 upon z, which is nothing but same as this limit. So the answer is 1. So the residue of f of z at point z equals to 0 is 1. So the correct option is option C. Note that you can use the Lorentz series expansion of this function to determine whether z equals to 0 is a pole of order 1 or not. Instead of this result, this second result, you can use the Lorentz series expansion of this function about z equals to 0 to determine whether z equals to 0 is a pole of this function, and if yes, then what is the order of that pole. So if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.